Beyond the last planets, where sunlight fades into the black, a lone traveler drifts. It is smaller than an automobile, fragile as a whisper, yet it carries with it the memory of an entire world. Voyager 1, humanity's first emissary to the stars. Its voice is faint, weaker than the static of a storm, a signal stretched thin across billions of kilometers. And yet, it endures, crossing a threshold no living creature has seen. Out here, there are no planets to orbit, no moons to survey. Only the deep, interstellar dark, but the silence is deceiving. Beneath the calm, space is alive with turbulence. Invisible tides of plasma flow like rivers. Magnetic fields twist and fracture. The edge of the sun's influence, once imagined as a simple boundary, is instead a storm, restless, shifting, unpredictable. Voyager, once built as a machine of certainty, now drifts as a witness to riddles no one foresaw. Each pulse of data it sends back is a fragment of mystery. Particles where none should be, silences where sound was expected. The path it follows is not the smooth departure science once promised, but a labyrinth through chaos, and as its power fades, as its voice grows quieter, one haunting question lingers in the silence. What becomes of a creation once it leaves its makers behind? Does Voyager drift into eternal obscurity, carrying only silence? Or does it become something greater, a mirror of humanity's yearning, a lost witness to the uncharted night? The journey of Voyager is not only a voyage outward, it is a reflection inward, a path through the cosmos and through the fragile wonder of those who launched it. From the earliest nights, long before machines traced the heavens, humanity looked upward and imagined journeys. Ancient myths spoke of wanderers who crossed the sky, Orion the hunter, Odysseus among the stars, the celestial boats of Egypt drifting on the Nile of night. Every culture wrote stories of voyagers, travelers not of oceans, but of the great Black Sea above. Though their ships were dreams, their longing was real. The idea of leaving Earth was etched into humanity long before it became possible. Centuries later, that longing deepened into science. Galileo turned his telescope skyward and found not a perfect heaven, but worlds, moons circling Jupiter, mountains on the moon, phases of Venus. The cosmos was not unreachable. It was a frontier. Johannes Kepler imagined cosmic harmony as music, planets moving to hidden rhythms. He called it the harmony of the spheres, the first whisper that journeys across the solar system might one day follow predictable paths. The modern age brought courage into reality. In 1957, Sputnik's faint signal crossed the atmosphere. A simple beep, but it told humanity that the heavens were open. In the years that followed, Gagarin orbited. Armstrong stepped onto the moon, and human ambition expanded beyond the cradle of Earth. Yet all these voyagers remained near, tied to the sun, bound to its light. The great expanse beyond the space between stars remained untouched. Distant as myth, by the early 1970s, astronomy revealed an opportunity. The outer planets, Jupiter, Saturn, Uranus, and Neptune, were aligning in a rare configuration. A celestial clockwork that would not repeat for another 175 years. This arrangement meant that a single spacecraft, if carefully launched, could visit multiple giant worlds in a single journey. It was called the Grand Tour, and it would become the foundation for Voyager. NASA engineers envisioned twin spacecraft, built not merely as machines, but as emissaries. Voyager 1 and Voyager 2, nearly identical, would leave Earth in 1977. Their mission, to fly by the outer planets, study them closely, and send back portraits of worlds no human eye had ever seen. They were modest in size, each no larger than a small car, with dish antennas like pale white faces turned toward Earth. Power came not from sunlight, which was to faint beyond Mars, but from radioisotope thermoelectric generators, converting the heat of decaying plutonium into steady electricity. They carried cameras, spectrometers, magnetometers, and plasma detectors. They were machines of science, yet they were also vessels of memory, for on their sides, bolted in gold, was a record. A phonograph disc, covered in protective casing, etched with instructions for playback. Inside, greetings in 55 languages, music from Batch to Blind Willie Johnson, sounds of whales, thunder, children, a kiss, and images of landscapes, mathematics, DNA, architecture, the diversity of life. It was called the Golden Record, a time capsule of Earth, if ever found by another intelligence. It would say, this is who we were. This is what Earth sounded like. Voyager 2 launched first, on August 20th, 1977, aboard a Titan IIIE rocket from Cape Canaveral. Voyager 1 followed on September 5th. They climbed beyond Earth's atmosphere, past the orbit of the Moon, into the outer dark. In their first encounters, they transformed knowledge into wonder at Jupiter. Voyager 1 revealed volcanic eruptions on Io, the first time active volcanoes had been seen beyond Earth. Europa appeared smooth, cracked, veined with ice, hinting at an ocean beneath its frozen shell. Ganymede and Callisto, giant moons, became worlds in their own right. The Great Red Spot, a storm larger than Earth, churned endlessly. The Jovian system was not a handful of moons. It was a miniature solar system, alive with chaos and motion. Voyager 2 confirmed these visions, then carried onward. At Saturn, the probes unveiled the complexity of the rings, not solid, but billions of icy fragments shaped by unseen moons. Titan, Saturn's largest moon, glowed with a thick orange haze. Scientists suspected an atmosphere rich in hydrocarbons, a possible mirror of early Earth. Voyager 1, after Saturn, was redirected upward, leaving the ecliptic plane of planets, beginning its journey toward interstellar space. Voyager 2 continued the grand tour. In 1986, it passed Uranus, revealing a tilted, rolling world with faint rings and a turquoise hue. In 1989, it reached Neptune, a blue giant with winds faster than any in the solar system, and the moon Triton, icy and active, with geysers spraying into space with those flybys. Voyager 2 completed humanity's first and only reconnaissance of all 4 outer planets. The missions had surpassed their goals. What had begun as a planetary survey became something larger. Beyond Neptune, there were no more planets to visit, no more encounters scheduled. The spacecraft were expected to drift outward, their cameras dimmed, their instruments gradually silenced. But silence never came, for beyond the planets lay the true unknown, the region no one had crossed, where the sun's domain ended and interstellar space began. Scientists realized that Voyager, though built for planets, could also be an explorer of the frontier. It carried instruments capable of sensing plasma, magnetic fields, and particles. If it lived long enough, it could measure the boundary between the heliosphere, the bubble carved by solar wind, and the interstellar medium, the heliosphere, they believed was a shield. a vast bubble inflated by charged particles streaming from the sun, stretching billions of kilometers in all directions. It protected Earth from cosmic rays, shielding the inner planets from high-energy particles that roamed the galaxy. Voyager, with time, would reach its edge. Beyond it, interstellar space, the great ocean between the stars. This possibility changed everything. What began as a finite planetary mission became an open-ended odyssey. The Voyagers were no longer only emissaries to the giants of the solar system. They were destined to be the first machines to leave the sun's protective cocoon. As the years passed, their distance grew unimaginable. Signals, traveling at the speed of light, took hours to reach Earth. By the mid-2000s, the spacecraft were over 100 astronomical units away, more than 15 billion kilometers. Their transmissions were weaker than a household light bulb heard across the continent. Yet the deep space network's massive radio dishes spanning California, Spain, and Australia could still detect their whispers, and those whispers carried mystery. At the boundary of the heliosphere, Voyager began to encounter strange phenomena. Plasma densities that spiked unexpectedly, magnetic fields that twisted in ways no models predicted, particles that surged and faded without pattern. The edge of the sun's influence, once imagined as smooth, was turbulent and alive. In 2012, Voyager 1's data shocked the world. It had crossed into interstellar space, but the evidence was conflicted. Instruments disagreed. Plasma density suggested one thing, magnetic fields another. Was it outside or still inside? Scientists debated fiercely. Voyager had reached a frontier that was not a wall but a storm. The sun's boundary was not fixed, but breathing, changing with the solar cycle. Voyager's path had carried it into riddles, not clarity. 6 years later, in 2018, Voyager 2 crossed as well. Its instruments, still more functional than Voyager 1's, recorded a different experience. It too entered interstellar space, but the data did not match. Two spacecraft, twins at launch, now described to different edges of the sun. The frontier was no single place, but a shifting, layered threshold. The Voyagers, born to study planets, had become pioneers of something greater, the first witnesses of the great boundary between stars. Humanity's dream of reaching the heavens, traced from ancient myth to modern science, now found its physical embodiment in two small machines drifting into the night. But discovery came with shock. What was thought to be smooth was turbulent. What was thought to be predictable was chaotic. And what was thought to be finite, a mission with an ending, had become infinite. For though the Voyagers may fade, their path continues, carrying them deeper into the dark, where no signal may ever return. The discovery phase of Voyager's journey was not just scientific, it was existential. These machines, crafted by human hands, had outlived their makers' expectations. They had touched the giants, captured their storms, and now moved beyond the sun's breath. They were no longer just spacecraft. They were symbols of curiosity, of fragility, of endurance. The Voyagers were humanity's first lost travelers, bound to no world, following a path into silence. And yet, in their silence, they became the loudest testimony that humanity once dared to send its voice beyond itself, that we built something small, and it went farther than we could, that our story, carved into gold, now drifts between the stars. The discovery had only begun, but already the mystery was larger than the mission. For decades, the Voyagers sailed outward with steady rhythm. Each year, their distance grew. Each year, their signals weakened. Scientists waited for the moment when they would pass through the boundary of the sun's influence into the interstellar medium. The edge was expected to be clear, a distinct threshold like the surface of an ocean meeting land. Models suggested a smooth transition. Inside, the solar wind dominated. Outside, the galactic plasma ruled. A line in the dark. But when Voyager reached that frontier, the universe revealed something stranger. What seemed simple became a storm. The heliosphere, once imagined as a perfect bubble, was found to be turbulent, irregular, and alive. Voyager 1's instruments began to record anomalies, puzzling shifts that defied predictions. Plasma waves spiked, rising to densities far higher than expected. Charged particles surged, then diminished. Magnetic fields twisted unexpectedly, still aligned as if tethered to the sun, even when other data suggested the probe had already left its domain. For years, scientists debated what these signs meant. Some said Voyager had entered interstellar space in 2012. Others argued it was still at the edge, within a liminal region neither fully solar nor fully galactic. The shock was not only scientific, it was philosophical. A boundary thought to be real dissolved into ambiguity. Voyager 2's crossing, 6 years later in 2018, only deepened the mystery. Its instruments, more functional than its twins, confirmed that it too had moved into interstellar space. Yet the conditions it encountered were different. Plasma densities rose, but not in the same way. Magnetic fields shifted, but not in the same direction. The two spacecraft, separated by billions of kilometers and years of travel, described boundaries that contradicted one another. The sun's edge, it seemed, was not a wall but a living frontier, expanding and contracting, shaped by storms of charged particles and magnetic tides. This realization was shocking. For centuries, humanity had imagined borders as fixed, the shore of an ocean, the surface of a planet, the edge of an atmosphere. Even space, though vast, was believed to have structure, the sun's domain ending where the galaxy began. Voyager revealed otherwise. The frontier was not solid, but dynamic. A storm, not a boundary. The heliosphere itself became a paradox. On Earth, the solar wind seemed steady, a continuous outflow of charged particles streaming outward at supersonic speeds. Yet at the far edge, where it met the interstellar medium, it behaved unpredictably. There were regions where the solar wind slowed abruptly, regions where it seemed to vanish, and regions where it mixed with galactic plasma in chaotic ways. Voyager's instruments captured data that shifted suddenly, like a compass needle spinning in a storm. Cosmic rays added to the confusion. These high-energy particles, born in distant supernova, were expected to surge once the spacecraft passed beyond the sun's shield. Yet their patterns were inconsistent. At times they rose sharply, as predicted. At other times they remained steady, as though still dampened by solar influence. It was as if the heliosphere allowed some cosmic messengers to pass freely, while trapping others in invisible currents. The scientific shock grew. Deeper when the Voyagers revealed that the interstellar medium itself was not the quiet emptiness once imagined. Plasma waves, detected by Voyager 1, vibrated like the resonance of an unseen ocean. These were not faint, they were dense, structured, and powerful. The medium between the stars, long thought to be thin and passive, proved to be alive with turbulence. For scientists, the contradiction was staggering. The heliosphere was not a neat bubble, and interstellar space was not empty. Instead, the universe at its frontier resembled a stormy coastline, shifting with unseen tides, shaped by forces larger than the sun itself. The shock echoed in the scientific community. Decades of models had assumed simplicity, symmetry, and predictability. Voyager replaced them with complexity, asymmetry, and uncertainty. The data was not merely difficult to interpret, it challenged the very idea that the boundary of the sun could be mapped in any simple way. Even more unsettling was the realization that humanity's most distant emissaries were fragile. Their power was waning. Their instruments, built in the 1970s, were failing one by one. Each anomalous signal could be the last. The possibility arose that humanity would never fully understand what Voyager had encountered, that the mystery of the boundary would remain unresolved, locked forever in incomplete data. Whispers too faint to decode. The sense of shock extended beyond science. Philosophically, it raised questions about knowledge itself. If the edge of the sun cannot be defined, if even the most carefully built probes return contradictions, what does it mean to know where humanity's home ends and the galaxy begins? Voyager's journey exposed not only the turbulence of the cosmos, but the fragility of certainty. Black holes had taught physicists that horizons were not simple. Einstein's relativity showed that time and space could bend, twist, and dissolve. But the heliopause, the supposed boundary of the sun, was expected to be different, measurable, and clear. Its ambiguity unsettled the scientific imagination. Voyager had been a machine of precision, designed to measure planets, moons, and magnetic fields. Yet in interstellar space, precision dissolved into paradox. The shock was not failure, but revelation that the frontier of the sun was not what humans had imagined. The golden records, carried aboard both Voyagers, added an emotional dimension. They were designed to last 1 billion years, adrift in the dark, a message for unknown finders. But as the spacecraft encountered contradictions at the sun's edge, a haunting thought emerged. The records might drift forever without leaving a clear origin. They would represent not only Earth's voice, but Earth's uncertainty, a testament to questions unanswered. The shock was not merely scientific, but existential. Humanity had believed the sun's domain to be defined, finite, comprehensible. Voyager revealed instead a shifting, stormy, unbounded frontier. The sun did not end. It faded, merged, and tangled with the galaxy. The path of the Voyagers was not into clarity, but into mystery. Scientists called it the heliopause, yet the word now felt misleading. It was not a pause, but a storm. Not an ending, but a blur. Voyager's greatest discovery was not what lay beyond, but that the very concept of beyond was uncertain. In this realization, the Voyagers became more than machines. They became metaphors for human knowledge, for exploration, for the shock of confronting the unknown. Their faint signals, carrying contradictions, whispered a profound truth, that the universe is stranger than models, richer than predictions, and deeper than certainty. The scientific shock of the Voyagers was not only in what they found, but in what they did not. They did not reveal a clear line. They did not confirm simple boundaries. They did not provide final answers. Instead, they left humanity with questions, and in those questions lay the essence of discovery. The path of the lost Voyager was no longer a journey into space. It was a journey into paradox, a reminder that the cosmos is not ordered for human understanding, but alive with storms that defy imagination. And so, as Voyager drifts outward, carrying the whispers of Earth. It leaves behind not clarity but shock, a shock that lingers, reshaping how humanity imagines its place in the universe. Beyond 13 billion miles, the Voyagers drift as solitary sentinels, whispering to Earth across the void. Their signals, faint as the breath of a candle in a storm, carry fragments of data, fragments that have become humanity's most precious evidence of what lies beyond the sun. Each transmission is not just information. It is an echo from a frontier no other human creation has crossed. At first, the data seemed simple: measures of plasma, cosmic rays, and magnetic fields. Yet, as scientists listened, a deeper story unfolded. What was thought to be empty became structured. What was thought to be silence became resonance. The Voyagers revealed that interstellar space is not a void, but an ocean. Voyager 1, the elder of the two, confirmed this in 2013, a year after its debated crossing into interstellar space. Its plasma wave instrument, once quiet for years, starved of the solar wind's hum, suddenly detected vibrations. When a solar storm erupted from the sun and sent shockwaves outward, those waves eventually reached the craft. The plasma around Voyager 1 sang in response, oscillating with measurable frequency. From that resonance, scientists could calculate its density. To their astonishment, the plasma was nearly 40 times denser than anything inside the heliosphere. The interstellar medium was no barren desert. It was alive with hidden structure. This was more than a measurement. It was proof that Voyager had truly crossed into a new domain. The stormy plasma of the galaxy itself had finally touched the probe. Yet the transition was not clear. Magnetic field readings still clung stubbornly to the orientation of the heliosphere. Even beyond the edge, the sun's influence lingered, like the fading pull of gravity on a departing traveler. Voyager 1 seemed to exist in two places at once, inside and outside. Solar and galactic. Voyager 2, with more instruments still alive, offered a second vantage point in 2018. Its data added clarity and contradiction. Plasma densities spiked again, confirming the richness of the interstellar medium. Yet the rise was smoother, less abrupt. Cosmic rays streamed in more freely, but their behavior differed from Voyager 1's measurements. The two crossings, separated by billions of kilometers and 6 years of time, painted pictures that did not align. The sun's edge was revealed as something shifting, layered, and asymmetric. On Earth, teams of scientists compared the data. They overlaid the plasma densities, traced the particle fluxes, mapped the magnetic fields. Each set of numbers contradicted the next. Yet in those contradictions, a pattern emerged. The heliosphere was not a static bubble, but a dynamic frontier, reshaped constantly by the solar cycle, by galactic winds, by unseen tides of charged matter. What Voyager described was not a wall, but a breathing boundary, swelling and contracting like the tide of an invisible sea. Beyond that boundary lay the interstellar medium itself, a region humanity had only imagined. Once dismissed as thin and empty, it now revealed itself as turbulent. Voyager's plasma instruments caught the vibrations of waves passing through it, echoes of distant supernova rippling across the galaxy. The probes showed that even between stars, the universe is alive with energy, shifting currents, and magnetic storms. The revelation was profound. Earth's environment, protected by the sun, is only a small haven within a larger galactic sea. Outside, radiation flows differently. Particles collide with unexpected force. Magnetic fields twist in ways that defy prediction. Voyager's instruments, though primitive by modern standards, revealed that the galaxy is not a calm expanse, but a restless ocean. The data also hinted at deeper mysteries. Why, for instance, did magnetic fields remain aligned with the heliosphere, even beyond the supposed edge? Were the sun's magnetic structures stretching farther than expected? Or were galactic fields being bent, twisted, and reshaped by their encounter? Voyager's weak signals carried no definitive answer, only questions wrapped in paradox. Scientists turned to comparisons. On Earth, the interstellar boundary explorer IBEX was mapping energetic neutral atoms particles born at the helium. Shooting back toward Earth, its images revealed a ribbon-like structure across the sky, a mysterious feature aligned with the local galactic magnetic field. Voyager's incited data and IBEX's remote sensing overlap, each confirming that the boundary was not smooth but streaked with structure, perhaps shaped by magnetic reconnection, the violent tearing and rejoining of field lines. The heliosphere was not a shield, but a sieve. For decades, cosmic rays had been a puzzle. These high-energy messengers from supernova and other cataclysms should have surged dramatically once the Voyagers passed beyond the sun's protection. Instead, the rise was uneven, as though some rays were still blocked. Scientists speculated that the heliosphere might trap certain particles in eddies, letting others slip through. Voyager had wandered into a frontier where the sun and galaxy intermingled, creating turbulence unlike anything on Earth. Even with their fading power, the Voyagers continued to surprise. Voyager 1 detected plasma waves repeatedly, each triggered by solar storms that had crossed the gulf of billions of kilometers. Each detection confirmed that the interstellar medium was structured, not silent. Voyager 2 measured temperatures of particles colder than expected, hinting at processes still unknown. Both probes revealed that the galaxy's plasma was far from uniform, shaped by distant explosions, tangled in magnetic webs, and constantly shifting. The deeper the investigation went, the more profound the implications became. The sun was not isolated. It was a Voyager itself, carving a bubble through the galaxy, colliding with its medium, shaping and being shaped by forces beyond comprehension. The Voyagers, in their silence, revealed that humanity's star was part of a grander storm. Yet even as science advanced, an emotional undertone persisted. Every new discovery came with fragility. The Voyager's instruments were failing. Their power, drawn from decaying plutonium, dwindled each year. To preserve their lifespans, engineers shut down heaters and instruments one by one, forcing choices between which mysteries to probe and which to abandon. The deeper investigation of the heliopause came at a cost, the slow death of humanity's first interstellar emissaries. In the control rooms on Earth, each faint signal was celebrated. Data packets arrived with long delays, over 20 hours for Voyager 1, over 18 hours for Voyager 2. Each bit of information was precious, each chart and graph a final glimpse into the unknown. The investigations were not just scientific, but elite. Humanity listened to the Voyagers not only for knowledge, but for the last whispers of machines that had traveled farther than anyone dreamed. The investigation also opened a new frontier of imagination. If this boundary was so strange, what lay farther out? The interstellar medium itself stretched for light years, filled with unknown currents, shockwaves from past supernova, and clouds of molecular gas. Voyager was barely beyond the shore, its instruments blind to much of what surrounded it. Yet the questions it raised pointed the way for future missions, to build probes designed not for planets, but for the galaxy itself. In this sense, the deeper investigation was not an ending, but a beginning. The contradictions in the data, the paradoxes of plasma and fields, were not failures of understanding, but seeds of new science. Voyager had shown that the galaxy is not empty, that the sun is not isolated, and that the edge of the solar system is not a line, but a storm. The investigation was incomplete, but it transformed the way humanity imagined its place in the cosmos. And so, the Voyagers drift onward. Their signals weaken, their instruments fail, but their legacy deepens. They are more than machines. They are mirrors, reflecting humanity's hunger for knowledge, its fragility, and its awe. Their deeper investigation revealed not only the turbulence of the galaxy, but the turbulence of discovery itself, the realization that knowledge is always provisional, always awaiting the next whisper from the dark. The path of the lost Voyager is not toward clarity, but toward paradox, and in those paradoxes lies the truth of the universe, that the cosmos is not still but stormy, not silent but resonant, not simple but infinite. The further Voyager drifted from the sun, the deeper the mystery became. The boundary once imagined as a clean line, a simple crossing from solar space into interstellar, night revealed itself as shifting, breathing, alive. What began as scientific triumph transformed into haunting contradiction. The heliopause, the outermost edge of the sun's influence, was thought to be static, a wall separating the familiar from the unknown. Yet the Voyagers revealed that it is no wall at all. It is a tide, solar winds rising and falling with the rhythm of the 11-year cycle, push outward like a great breath. Interstellar plasma, dense and cold, pushes back. The two forces meet in conflict, not equilibrium. Boundaries swell and retreat, like waves against a shore, their positions shifting by billions of kilometers. This means Voyager's passage was not into a new domain once and for all, but through a moving frontier, a frontier that may recede or advance long after the probes themselves fall silent. The line between inside and outside is blurred. The very concept of borders, so vital to human imagination, falters at cosmic scales. The cosmic rays confirmed this. For decades, scientists predicted that beyond the heliopause, galactic radiation would surge dramatically, no longer shielded by the sun. But the Voyager's instruments told a different story. Some particles increased, but others behaved strangely, streaming in uneven bursts, as though trapped in hidden channels or caught in eddies at the edge of the bubble. Instead of a simple on-off transition, the cosmic rays revealed a region of turbulence where forces mixed unpredictably. The shield of the sun was not broken cleanly. It frayed into threads. Magnetic fields only deepened the riddle. Voyager 1's magnetometer, still faintly operational, detected fields beyond the boundary, but to the astonishment of scientists, their orientation was nearly the same as inside the heliosphere. If the probes were truly outside, why did the sun's magnetic signature still dominate? Was the heliopause more porous than expected? Was interstellar space itself bending around the solar bubble, aligning to its shape? The mystery remains unresolved. Voyager's path is a riddle written in magnetism. As the probes pushed outward, the sense of escalation was not only scientific, but existential. Each measurement was accompanied by a countdown. Their power supply, radioactive decay of plutonium-238, diminishes each year, robbing them of instruments, heaters, voices. Systems are shut down in sequence, like senses going blind one by one. Soon, only a few instruments will remain. Eventually, even the transmitter will fall silent. The lost Voyagers are not immortal. They are fragile machines racing against time. Their revelations shadowed by the knowledge that each could be their last. This impermanence sharpened the mystery. Plasma oscillations, recorded by Voyager 1, revealed that the interstellar medium was not uniform but punctuated by density waves, likely remnants of ancient supernova. These echoes, crossing light years, reached the craft like the faint tremors of a distant storm. Each vibration was evidence that the galaxy is not still, but shaken by the deaths of stars. Voyager had stumbled into a sea that remembers. Yet with each passing year, the instrument that listens to those echoes grows colder, weaker, closer to silence. The turbulence also challenged humanity's models of cosmic protection. Earth lives in the shadow of the heliosphere, shielded from the full violence of galactic radiation. But if the boundary is unstable, porous, ever-changing, then so too is our protection. Cosmic rays are not simply deflected. They seep through, guided by shifting magnetic structures. Life on Earth is shaped by this unseen battle, dependent on a frontier whose behavior, even now, cannot be fully described. The Voyagers showed that our safety is contingent, precarious, fragile. The mystery deepened further with time. In 2019, Voyager 2 crossed the heliopause, 6 years after its twin. Its readings echoed those of Voyager 1. Plasma densities rising sharply, particle counts shifting, but the details differed. The boundary was closer, the transition smoother. The interstellar medium on its side was colder, more compressed. The two probes, though separated by only a fraction of the solar system's diameter compared to the galaxy, told stories that diverged. The heliopause was not a uniform sphere, but a lopsided, wrinkled surface, distorted by both solar winds and galactic pressures. The edge of the sun is not a single edge, but many, layered and uneven. In this lies a profound truth. The heliosphere is not simply a bubble around the sun, but a living structure, distorted by every gust of stellar wind. Every passing current of interstellar plasma, it breathes, it changes. And Voyager, drifting blind through it, has revealed that humanity's solar system is less an island and more a vessel adrift in a storm. Yet perhaps the most haunting escalation came not from plasma or rays, but from silence itself. Voyager 1's communications began to falter in 2022, when an onboard system sent corrupted data back to Earth. Engineers worked tirelessly to resolve it, coaxing the ancient craft back to clarity. But the incident was a warning. The probes are aging, their instruments degrading, their memories failing. Their path will soon vanish into a silence deeper than space. Humanity will never know what they encounter beyond their last whisper. This realization is both humbling and unsettling. For all their triumph, the Voyagers are limited. They have reached only the first step into interstellar space, a distance of less than a light day into a galaxy spanning 100,000 light-years. Their mystery is not the galaxy itself, but merely its shore. Yet even here, the turbulence is overwhelming. What then lies farther out? If the edge of the sun's domain is this chaotic, what structures and storms await in the true depths of interstellar space? The question grows more profound when placed in cosmic perspective. The sun is not unique. Every star generates its own heliosphere, its own bubble of influence. Across the galaxy, billions of these structures collide, overlap, and tangle. Voyager's revelations suggest that the interstellar medium is not uniform at all, but sculpted by these interactions, bubbles colliding like foam upon the surface of an ocean. The mystery is not just about our own heliosphere, but about the architecture of the galaxy itself. Here, the escalation becomes philosophical. Voyager is not merely lost. It is a metaphor for humanity's own trajectory. We to move outward, probing boundaries, confronting contradictions. Each discovery deepens uncertainty rather than resolves it. The more we learn, the less clear the edges of knowledge become. The path of the lost Voyager is our path, one where answers dissolve into new questions, where certainty is replaced by paradox. And so, the mystery deepens. The probes continue to drift, carrying their golden records, their faint instruments, their fragile voices. They measure plasma waves, magnetic storms, cosmic rays, and in those numbers lies the revelation that the universe is stranger than imagined, more turbulent, more fragile, more alive. Yet the escalation is also emotional. Soon they will fall silent, leaving humanity alone with questions that may never be answered. The frontier, they revealed, is not only physical but existential. The heliopause is no boundary but a storm. The interstellar medium is no void but a sea. The Voyagers, once thought to be explorers of certainty, have become witnesses of paradox. And the deeper they go, the less clear their path becomes. What lies ahead? Only silence. Only mystery. Only the haunting knowledge that the universe is far more restless than we believed. When Voyager left the embrace of the sun, it did not leave behind certainty. It entered ambiguity. Each signal received on Earth was both a clue and a contradiction, a fragment of truth suspended in silence. To make sense of this frontier, scientists turned not only to data, but to theory, to speculation rooted in mathematics, to imagination constrained by physics. The first theory redefined the heliosphere itself. For decades, it was drawn in diagrams as a sphere, inflated like a balloon by the solar wind. But Voyager's path revealed distortions, asymmetries, irregularities. The new vision is not a sphere, but a comet. The sun trails a vast, elongated tail as it moves through the galaxy, its bubble stretched by the drag of interstellar winds. Voyager, by chance, did not pierce the bubble's nose or its tail, but its side, where turbulence reigns. The edge, in this picture, is not a wall but a wake, a frothing, comet-shaped shield pulled thin against the currents of the galaxy. Another theory points to magnetic reconnection. At the heliopause, the sun's magnetic field clashes with that of the interstellar medium. These lines, like taut strings, snap and reconnect, releasing bursts of energy, opening holes through which particles leak. Voyager's odd readings of cosmic rays may be the result of such reconnection, where the barrier is not uniform but pocked with gateways. In this image, the heliosphere is not a fortress but a sieve, riddled with shifting apertures through which the galaxy peers back at us. Some imagine the heliosphere not as an isolated structure but as part of a vast interstellar architecture. The sun is one among billions of stars, each with its own bubble. Where these bubbles press together, magnetic boundaries collide, cosmic rays scatter, and turbulence amplifies. Voyager's contradictions may not be local oddities, but signs that our solar system is but one cell in a galactic foam. The galaxy, in this picture, is not empty but frothy, bubbles colliding endlessly, their walls alive with storms, Still more daring is the suggestion that cosmic rays themselves shape the frontier. High-energy particles, born in the remnants of supernova, slam against the heliopause, warping it, distorting its boundaries. Voyager's passage may have coincided with a region of heightened bombardment, its instruments recording not constants but scars. The path of the probe, then, is less a neutral crossing than a witness to the violence of galactic weather. Yet the strangest speculations reach beyond plasma and fields, into the realm of the exotic. Some theorists whisper of dark matter, that invisible mass permeating galaxies. Could dark matter interact subtly with charged particles at the heliopause? Could its presence bend the flows Voyager detects? No evidence confirms this, but the possibility lingers, a reminder that what we call anomalies may be shadows of physics not yet discovered. Even more unsettling is the idea of vacuum fluctuations at the boundary. Quantum theory predicts that empty space is never empty. Virtual particles flicker into existence, then vanish. In the cauldron of the heliopause, where fields collide and energies spike, might these fluctuations magnify, producing effects that Voyager has glimpsed but cannot explain? If so, then the edge of the sun is also an edge of reality, where quantum storms rise into macroscopic form. Other models revisit the very shape of time. If space is curved, if dimensions fold, then perhaps the heliopause is not merely a spatial border but a temporal threshold, where flows of particles trace patterns not fully linear. Voyager's data, contradictory and incomplete, might be the first hints that time itself behaves strangely in the turbulence between star and galaxy. These theories, though varied, share a haunting quality. They admit uncertainty. Each possibility replaces the simplicity once imagined with complexity beyond comprehension. The heliosphere may be comet-shaped, porous, colliding with neighbors, warped by cosmic rays, punctured by magnetic reconnection, shadowed by dark matter, even stirred by quantum seas. Voyager, in its frailty, has not chosen among them. It has whispered only that the truth is stranger than prediction. Speculation also extends to the future. If the Voyagers survive for millions of years, they will drift far beyond the heliosphere, through interstellar clouds shaped by long-dead stars. Some theorists imagine that their golden records, sealed against time, may one day be found not by humanity, but by another civilization. In this vision, Voyager is not only an instrument of science, but of destiny, carrying Earth's voice across epochs, through regions where no human knowledge has ever reached. There are even more radical ideas. Some scientists wonder if the heliosphere itself shapes the conditions for life. By shielding planets from galactic radiation, it creates a habitable zone not just within the solar system, but around the solar system itself. If this is true, then Voyager has revealed not only the structure of the sun's influence, but the architecture of survival. Life on Earth may exist not merely because of distance from the sun, but because of distance within its bubble. The edge that Voyager crossed is not simply physical, but existential. Beyond science, speculation shades into philosophy. What does it mean that the first emissaries of humanity are adrift in turbulence, their path uncertain, their data incomplete? Some see it as a metaphor for knowledge itself. Each discovery erases clarity, replacing it with complexity. Others see it as a lesson in humility. The universe is not obligated to make sense in human terms, and our instruments are but brief candles against its storm. And yet, amid uncertainty, there is wonder. Theories multiply because the Voyagers revealed more than expected. They forced humanity to confront the limits of its imagination. In their silence, they continue to speak. In their contradictions, they continue to guide. Perhaps the most poetic speculation is this, that the Voyagers are not merely machines, but participants in the cosmos. They are witnesses whose presence alters the story, whose drift through interstellar space entwines human destiny with galactic tides. In their path lies not only science, but meaning. They remind us that to venture outward is to risk confusion, that to search for answers is to encounter mystery. Theories abound, speculations multiply, but in the end, Voyager is not lost because its path is unknown. It is lost because it has carried us beyond the reach of certainty, into a realm where knowledge dissolves into questions. Its journey is not a failure of clarity, but a triumph of wonder, proof that even silence can speak, if one listens deeply enough. And so the theories remain: comet-shaped heliospheres, magnetic reconnection, galactic foam, cosmic ray scars, dark matter, shadows, quantum turbulence. Each is plausible, none is proven. The true shape of the frontier may never be known. Yet in this ambiguity lies the greatest revelation. The universe is not static, not simple, not predictable. It is alive with storms we cannot see, alive with mysteries we cannot solve. Voyager has not only discovered this truth, it has become its symbol. The lost Voyagers drift still into the night through turbulence and speculation, bearing with them the lesson that the unknown is not emptiness, but depth. Their path is uncertain, their data incomplete, but their meaning is eternal. They remind us that to explore is not to conquer, but to wonder. And in that wonder, humanity finds both its limits and its light. Voyager's whispers drift across the void, faint signals caught by antennas on Earth the size of cathedrals. Yet even as these aging emissaries fade, humanity continues to listen and to prepare. The questions they have raised are too vast to leave unanswered. If the heliopause is not a wall but a storm, if the interstellar medium is alive with turbulence, then new instruments must be built, tools that extend our senses beyond the frailty of the Voyagers. The first of these is IBEX, the Interstellar Boundary Explorer. Launched in 2008, unlike Voyager, which touched the boundary directly, IBEX observed from afar, mapping energetic neutral atoms that stream back toward Earth from the edges of the heliosphere. What it revealed astonished scientists: a bright ribbon of emission, an arc across the sky that no model had predicted. The heliosphere was not uniform, but patterned, textured, stitched with forces we barely understood. IBEX became humanity's first wide-field mirror of the frontier, an abstract portrait of the storm into which Voyager wandered. Its successor, IMAP, the Interstellar Mapping and Acceleration Probe, scheduled to launch in the mid-2020s, promises sharper vision. Where IBEX painted a rough sketch, IMAP will draw detail, tracing the flows of particles, decoding the boundaries where solar wind collides with galactic breath. For the first time, humanity may not only guess, but see the structure that contains it. Closer to home, the Parker Solar Probe dives into the sun's own furnace, skimming its corona, measuring the birth of the solar wind that inflates the heliosphere. By understanding the source, scientists can better grasp the shield it creates, the bubble that Voyager pierced. Parker's data, though local, reflects outward. The boundary cannot be known without knowing the breath that sustains it. New Horizons, though launched toward Pluto, continues outward. Its instruments, more advanced than Voyager's, still record the faint whispers of the heliosphere. Though it will not reach the boundary for decades, it carries lessons forward that probes designed with longevity can become scouts, evolving from planetary explorers to interstellar pilgrims. On Earth, cosmic ray observatories complement these missions. Facilities like the Pia Auger Observatory in Argentina or detectors deep underground in Japan and Canada record high-energy particles that slip past the heliosphere's defenses. By correlating their flux with solar cycles and ibex maps, scientists weave a picture of how the frontier breathes. Voyager measures the edge directly. Earth measures the rain that falls through it together. They sketch the storm. The next step is ambition incarnate, the proposed interstellar probe, designed to travel 10 times farther than Voyager within 50 years. It would carry instruments tuned to plasma, fields, and particles. Its mission would not end with planets, nor linger at the boundary, but press into interstellar space deliberately, its path chosen rather than accidental, where Voyager stumbled as a relic of planetary exploration. The interstellar probe would stride with intent humanity's first craft, designed to leave the sun forever. Even more distant tools promise broader context. The Verisi-Rubin Observatory will map faint galaxies, tracing the galactic environment into which the sun sails. Euclid, launched by ESA, will map dark energy's imprint, refining our models of cosmic expansion. Together, they frame the ocean in which the heliosphere drifts. Voyager's turbulence is not isolated. It is shaped by the galaxy's tides, gravitational wave detectors, to add to the chorus. LIGO, Virgo, and the planned space-based LISA detect ripples from black holes and neutron stars. These events, exploding across the galaxy, stir the interstellar medium, shaping the very currents Voyager has begun to feel. In every signal of space-time trembling, there may be an echo of the storm through which our probes sail, and yet, the most delicate instruments may be those of the quantum age. In laboratories chilled to near absolute zero, ultra-cold atoms mimic plasmas, simulating turbulence at scales unreachable in space. In these miniature universes, scientists recreate conditions akin to the heliopause, watching as magnetic lines snap, reconnect, and surge. The storm is not only out there. It can be summoned in silence, glimpsed in glass chambers lit by lasers. All these tools converge toward a single goal: to see what Voyager has touched but not resolved. Each mission, each detector, each simulation is a lantern lit against the darkness, extending human vision farther than frail machines can travel alone. But the urgency grows. Voyager's instruments fail, one by one. Their plutonium hearts cool, their whispers weaken. The moment approaches when no more data will come, when the lost Voyagers will drift in silence forever. What they have begun must be continued by others. IBEX maps, IMAP surveys, Parker dives, New Horizons drifts, interstellar probes launch. The chain must not be broken, for the mystery remains unsolved. Even as science builds tools, philosophy lingers. Each mission is an act of faith, that by building instruments, we may understand storms no human will ever touch. That maps drawn from whispers are worth the labor of generations. That knowledge is not measured only in answers, but in persistence. The scientific pursuit is not mechanical, it is existential. To chart the heliopause is to chart the edge of safety. To measure cosmic rays is to measure the breadth of survival. To send probes into the galaxy is to declare that the human voice will not be confined. Every antenna raised, every detector chilled, Every mission launched is a continuation of Voyager's first step. One day, perhaps centuries hence, probes will sail beyond the local bubble, into regions sculpted by ancient supernova. They will taste plasma enriched with heavy elements, magnetic fields bent by stellar deaths. They will see the galaxy not as light but as wind. When that day comes, the data of Voyager will be remembered not as confusion, but as prologue, the first murmur of a story still being written. And so the tools grow. From orbiting observatories to underground detectors, from solar divers to interstellar scouts, humanity builds an orchestra of sensors. Together, they continue the path of the Voyagers, each note resonating with the same question. What lies beyond the sun's last breath? The scientific instruments of today are not replacements for Voyager, but companions. They extend its voice, amplify its whispers, ensure that when silence comes, the listening does not end. The storm beyond the heliosphere has only begun to reveal itself. The work of mapping it, of naming it, of understanding it, belongs not to one probe, but to a lineage. Voyager showed the way. The next generation must follow. In the silence between the stars, two small machines drift. Their antennas no longer hear Earth clearly. Their instruments grow tired, their hearts of plutonium dim with every passing year. Yet they sail onward, blind but unbroken, carried by momentum into a night without end. Voyager 1 and Voyager 2, children of the 20th century, wander now where no human voice has ever traveled. Theirs is a paradox. They are the most distant of all human-made things, yet the least free. Their path was set the moment they were launched, their trajectories inscribed in the mathematics of gravity and speed. They are Voyagers, but they are also orphans, cut loose from their makers, unable to turn back, unable to change course. And yet, in this exile, they have become something more than probes. They have become symbols for what is a Voyager, if not a reflection of the human condition. Humanity, too, was launched, cast into existence, propelled into time's current, unable to return to the beginning. Like Voyager, humanity drifts outward into a cosmos vast and indifferent. The universe does not call back, does not guide, does not promise. Yet still, like Voyager, humanity sends signals into the dark, hoping they will be heard. The golden records aboard each craft whisper greetings in 55 languages, carry the music of Bach and Beethoven, the heartbeat of a mother, the sound of wind and rain. These are not scientific instruments, but offerings, fragile proof that a world once existed, where thinking beings looked upward and longed for contact. Perhaps no one will ever hear them. Perhaps no one will ever find them. Perhaps they will drift forever, their grooves unplayed, their messages unread. Yet that, too, is meaning. To place a message in a bottle and cast it into an endless sea is not folly. It is faith. Faith that existence matters. Faith that loneliness is not eternal. Faith that silence can be broken. In this sense, the path of the lost Voyagers is not their own, but ours. They carry not data alone, but metaphor. They remind humanity that exploration is not about answers, but about endurance, about choosing to wander even when the destination is unknown. Consider the horizon they crossed, the once imagined a border, revealed instead as storm and turbulence. The lesson is clear. The boundaries of understanding are never walls, but oceans. Every crossing leads not to certainty, but to greater mystery. Voyager has shown that leaving home does not end questions. It multiplies them. And so it is with life itself. To live is to step across horizons, knowing they will never resolve into final clarity, but trusting that the act of crossing matters. One day, the voyagers will fall silent. Their transmitters will cool, their instruments will darken. Earth will no longer hear their whispers. Yet even then, they will continue, mute but eternal. For 1 billion years they will drift, passing stars, skimming through clouds of dust, circling the galaxy like pollen on a breeze. Long after mountains on Earth have worn away, long after oceans have dried, the voyagers will remain. They are not only lost, they are enduring. Perhaps one day, distant beings will find them. Perhaps they will lift the records, study the diagrams etched into gold, and listen to the music of a vanished world. Or perhaps no one will. Perhaps the voyagers will remain unclaimed monuments to silence. But even in that, there is beauty. For the value of the golden record is not in being heard, but in having been made. It proves that humanity, fragile and finite, chose to speak, and if the voyagers vanish, if they are never found, still they are not wasted, for their path has already changed humanity. They have shown that the edge of the sun is not the edge of knowledge. They have shown that frail machines, no larger than cars, can rewrite what it means to explore. They have shown that exploration is not conquest, but humility, the act of admitting ignorance and sailing into it anyway. Their silence, when it comes, will not be tragedy. It will be transformation. The baton will pass to future probes, to missions yet unborn, to generations not yet imagined. The voyagers are not ends but beginnings, not conclusions but preludes. Their path will be followed, their silence filled by new voices, but still a question lingers. When humanity looks at the voyagers, what does it see? A machine drifting without purpose, or a mirror reflecting its own longing? The answer depends not on the probes, but on humanity itself. For the voyagers are not lost. They are exactly where physics has carried them. It is humanity that is lost, searching for meaning in a cosmos that offers none freely. And yet, perhaps, meaning is not given. Perhaps it is made. Voyager proves that to make meaning is to endure, to carve a message into gold, to whisper it into the void, to accept that silence may be the only reply, and still to send it anyway. That is meaning. That is defiance. That is the essence of being. The path of the lost voyagers is our path. We, too, drift between horizons, uncertain of endings, haunted by silence, buoyed by wonder. We, too, carry records, not of gold, but of memory, of culture, of hope. We, too, will fall silent one day. But in the time between, we can choose to send our voices outward. And so, the narrative closes not in despair, but in reflection. Voyager is lost, yes, but not defeated. Its path is endless, and in that endlessness lies truth. The universe may be vast, cold, and silent, but within it drifts a fragile echo of humanity, a machine that whispers still. The final meditation returns to the haunting question: what becomes of a creation once it leaves its makers behind? Voyager's answer is both simple and profound. It becomes a witness, a testament, a reflection of its maker's longing. And in that reflection, humanity sees itself small, wandering, uncertain, yet luminous. For in the end, the path of the lost voyager is not about where it goes. It is about what it reveals, that even the faintest signal, cast into the infinite night, can endure as proof that life once dreamed among the stars.